All right. Hey, everybody, this is Miss Peachy from your WCA Earth and Space Science class, and today we are looking at Unit 1, Lesson 3 on measurement. And I wanted to do a short video just to kind of go over some of the concepts you have in this lesson. Specifically, we're going to be looking at the different types of measurement, the ways we can quantify measurement, and then also the different systems of measure that you may encounter. So the first one here we have is circumference. These are our different quantities. So how do we measure stuff? What are some of the ways in which we can measure? So circumference is a measure around something. So if I want to know the circumference, I measure around it, the outside of it. So we can measure the circumference of this. This is a little container that I have with paper clips inside, right? So I can just measure all the way around here, and we'll measure that as a distance measure, but it's a circumference. And that's one example of a measurement. We can also measure the volume of something. We can measure the volume of liquid, for example, in this little spray bottle that I have. That's a liquid volume. Or perhaps the amount of hand sanitizer that I have here in this little bottle on my desk. That's volume in liquid. We can also measure solid volume. Like I have this little wooden plaque thingy on my desk here. Um, and you can measure, for example, height and width and depth, or length times width times height, right? That's going to give us the measure of solid volume of that particular object. That's a rectangular solid, so they're easier to measure. Things that are a little bit more irregular, like this little piece, this is actually a really cool piece of petrified wood. So look at that, isn't that neat? It's not it's stone, but it looks like wood. I can measure the volume of this using a really cool method called displacement, where I may have like a beaker of water, and then I can measure the liquid volume, and then I can drop this into the beaker of water, and the volume on the water in the beaker will go up, and the difference between the beginning volume and the ending volume is the measure of the volume of that object. I can measure the quantity, how many of something there is. For example, you guys could count how many highlighters does Mrs. Peachy have in her highlighter cup on her desk? That's a quantity measure. And you can measure mass. That's the amount of matter in something. Usually we do that in grams or kilograms. We actually look at it on a scale. We can measure the mass. We can measure temperature, how hot something, how much heat something has using temperature. Those are all different ways in which we can measure. There's other things. For example, we can measure length and width. We can measure speed. We can measure I have weight on here, and weight differs from mass in that weight is the effect that gravity has on the object that has mass. So those are two different measurement systems and different or measurement. Those are two different. Those are different measurement quantities, and these are our two different measurement systems. That's what I'm trying to say here. So we use the metric system and the US system, which is also known as, or used to be known as like the imperial or English system of measure. It's called the US system because the US is one of the only developed nations that actually still uses this system of measurement for stuff. Um, so in the US, we measure length in feet and inches, right? So I am 5'9" tall. I'm very tall. That is the measurement of length in the US system. In the metric system, we would use meters instead. In the US system, we use pounds, whereas in the metric system for weight, we would use newtons. Or perhaps kilograms, which is a measure of mass. So most people, if they give you their weight in the metric system, will likely give you their mass instead of their weight. And we can measure. One moment, we can actually measure their speed. In the US system, we use miles per hour. That's what you guys will be familiar with because it will be on your dashboard of your car when you're actually driving. It will be in miles per hour. Speed is in kilometers per hour. Sometimes we use meters per second. In the metric system for the US system, we use gallons and quarts and cups and things for liquid volume. Um, whereas we use liters and milliliters and deciliters for liquid volume in the metric system. For the solid volume, like I talked about earlier, we don't use liters. And instead, we would use things like cubic centimeters or cubic meters or something like that. And then for temperature, metric system, it's Kelvin, and Celsius. US system is degrees Fahrenheit. So why do we talk about this? Because science uses the metric system more so than any other system of measure. In fact, almost exclusively using the metric or the SI system of measurement. SI system stands for System International, and it basically is the metric system, although there are some preferences. For example, the SI system specifically uses Kelvin and not Celsius degrees, but we kind of use both here in science as well. And what makes it much more preferred than using the US system is that it is what we call a base 10 system of measure, meaning every unit is based on the number 10. Say, for example, in my metric ruler, which I have right here, right? There are 10 centimeters in a decimeter. In every centimeter, which is really hard to see, there are 10 millimeters in a centimeter. There are 10 decimeters in a meter, or 100 centimeters in a meter, right? And so then there's 10 meters in a decameter, and so on and so forth. We can just keep going up by a factor of 10. And that's kind of nice because it's easy to multiply and divide by 10. So it's easy to convert very easily within the metric system. You can easily convert from centimeters to meters with just moving some decimal places. So on the second slide here, we talk about mass. Again, mass is different than weight. Mass is inherently the amount of matter in something, whereas weight is actually the pull of gravity and how it affects that person or that object's mass. So the classic example is my mass on Earth is the same as my mass on the moon, but if I were to step on a scale on the Earth versus on the moon, my weight would actually go down because the gravity on the moon is lower than that on the Earth. So gravity is going to actually affect your weight and it will not affect your mass. So mass is a constant and gravity or weight by gravity is not. Temperature, we have those three scales, Fahrenheit, Celsius, and Kelvin. So as you kind of see how they compare, 0 degrees Celsius is equivalent to 32 degrees Fahrenheit, and 100 degrees Celsius is equivalent to 212 degrees Fahrenheit. What's kind of tricky here is, and you can't really see it in this image, is that 1 degree Celsius does not equal 1 degree Fahrenheit. So if I move up and down the scales, I'm not equal, it's not the same amount of change in temperature. On the other hand, 1 degree of Celsius is equal to 1 degree of Kelvin. So if I move up and down the scale by 1, it is the same on both of those scales. Kelvin is based on the 0 being absolute 0, like nothing could ever go colder than that. This is the temperature at which all molecular motion completely would stop. And so that is absolute. There are 0. There's no negatives in the Kelvin scale. And that's what makes Kelvin kind of cool. There's no negatives. So 0 is absolute 0. And that means that freezing point of water is actually 273 degrees Kelvin. By the way, I'm saying degrees Kelvin and I'm actually wrong because we don't say degrees, we just say Kelvin. So instead of saying 273 degrees Kelvin, we would just say 273 Kelvin. I don't know why they don't use degrees there, but they don't. Volumes, again, volumes of liquid is measured based on the amount of, put it in a container and you see how much space it takes up. And when we measure volumes of liquid, we are using like ounces and quarts and gallons in the US system. And in the metric system, it is milliliters, liters, decaliters, kiloliters, things like that. Also, with liquid volume, if you remember, we actually have something kind of cool when you look at, and I don't have it I don't have a great example here, but when you look at something with liquid volume, there's always going to be a bit of curvature where the water kind of curves here. And that has to do with the properties of water. But when we're measuring the volume in a liquid, we would always measure from the bottom of where that curve is. That's called the meniscus. So we measure the bottom of that curve right there. You don't want to measure the top of the curve because it's a difference in volume. And the volume of a solid we use measured by length, width, and height, like I said before, or we can use that displacement method like I talked about earlier. And then finally, time. And time is measured in various units. Generally, the standard unit for measuring time is in seconds. So we do things like meters per second or kilometers per second. So that kind of gives you an overview of measurement, both the quantities and the different systems of measure as well. All right, let's see here. Thank you guys for watching this video today. If you have any questions or concerns, feel free to give me a call or you can send a webmail message. Have a great day.